Have you ever stopped to consider how much we don't know about our own cosmic backyard? What if I told you there could be an entire world lurking in the deep, cold abyss of our solar system, so far flung that a single journey around the sun would eclipse the entirety of recorded human history, taking a staggering 20,000 years? This isn't the stuff of science fiction blockbusters. It's one of the most electrifying and baffling possibilities astronomers are wrestling with right now. They call it Planet 9. Imagine a phantom world, invisible to our most powerful telescopes, yet its immense gravity could be subtly shaping the destiny of countless icy bodies at the very fringes of our solar neighborhood. It's a cosmic puppet master pulling strings from the shadows. To truly grasp why the sharpest minds on Earth even entertain such an audacious idea, we need to journey back in time to a moment that sent shockwaves through the scientific community and fundamentally altered our understanding of what a planet truly is. In 2006, the world received a collective jolt. Pluto, the beloved ninth planet from our childhood textbooks, was unceremoniously stripped of its planetary status. With a single controversial vote by the International Astronomical Union, it was demoted to a mere dwarf planet. School curricula were rewritten, planetary mobiles were redesigned, and our solar system, once thought to contain 9 grand worlds, suddenly consisted of a tidy, yet perhaps incomplete, 8. But what if that neat 8-planet count was merely a placeholder, obscuring a far grander and more mysterious truth? Less than a decade after Pluto's fall from grace, 2 brilliant minds at Caltech, Konstantin Batygin and Mike Brown, the very astronomer often dubbed Pluto Killer for his role in its reclassification, dropped another bombshell. They proposed the existence of another massive world, hidden in the perpetual twilight far beyond Neptune's familiar embrace. Their groundbreaking hypothesis wasn't born from a wild hunch or a late-night fantasy. It emerged from careful, painstaking observation of the Kuiper Belt. Picture the Kuiper Belt as a colossal, icy debris field, a vast ring of frozen remnants orbiting the Sun far past Neptune. Most of the objects here follow predictable, well-behaved paths, but a peculiar handful, initially just 6, seemed to defy all logic. They were strangely clustered, their elongated orbits tilted and aligned in a way that statistically should not be possible. It was as if an invisible shepherd, an immense gravitational force, was herding them, bending their paths into this unusual celestial ballet. The mathematical odds of such a pattern occurring purely by chance? A staggering 1 in 15,000. These were not random occurrences. This was a cosmic whisper demanding attention. Batygin and Brown embarked on a series of elaborate computer simulations, posing a profound question. If a hidden planet were out there, what kind of world would possess the gravitational might to sculpt the orbits of these distant icy objects in such a precise and unusual manner? The models began to paint an astonishing portrait, a giant world smaller than Neptune or Uranus, yet still an imposing 5 to 10 times more massive than Earth. Unlike the familiar gas giants of our inner system, this hypothetical behemoth would reside in unimaginable isolation, perhaps 20 to 30 times farther from the Sun than Neptune itself. At such a profound distance, our mighty Sun would appear as little more than a slightly brighter star in its alien sky, and a single year on Planet 9 would span an epoch longer than the entire recorded history of human civilization. This phantom planet's orbit would be as peculiar as its existence. Instead of adhering to the relatively flat plane shared by the other planets, it would be dramatically tilted and stretched out into a highly elliptical path, almost as if it were a rogue conductor marching to its own cosmic beat. This extreme, off-kilter placement could elegantly explain why those distant Kuiper Belt objects appear to be both tilted and clustered together, held captive by Planet Nine's unseen pull. But here's the colossal catch, the frustrating reality of deep space exploration. If a planet is that incredibly far away, finding it is an astronomical needle in a haystack endeavor, akin to trying to spot a single grain of sand in the heart of a desert at night without a flashlight. Astronomers have no definitive idea where along its immense meandering orbital path it might be at any given moment. It could take decades or even centuries before our technology and observational prowess are sharp enough to finally pin it down. Of course, not everyone in the astronomy community is entirely convinced. History, after all, is littered with tantalizing claims of unseen planets that ultimately proved illusory. Back in the 1800s, scientists observed that Uranus wasn't moving exactly as predicted. They suspected the gravitational tug of another unseen planet, a suspicion that famously led to the triumphant discovery of Neptune. However, hot on the heels of this success, some began to hypothesize yet another planet beyond Neptune, attributing further irregularities in Uranus's orbit to this elusive Planet X. This extended search eventually led to the discovery of Pluto, but it soon became clear that Pluto was far too diminutive to exert any significant gravitational influence. Later, more precise measurements revealed that the perceived irregularities in Uranus's orbit weren't even real in the first place. The lesson was learned. The astronomy community has become rightfully cautious, even skeptical about such grand claims. Yet despite this historical precedent, the Planet Nine hypothesis has generated a profound and sustained buzz. Some recent rigorous studies even suggest a tantalizing 40% chance of its existence, a figure far too significant to dismiss. Other theories propose that Planet Nine might have been a rogue world, gravitationally ejected from the inner solar system eons ago, banished to the cold, distant outskirts where its detection has become an almost impossible quest. On the flip side, skeptics eagerly point to newly discovered icy bodies that simply don't conform to the predictions of the Planet Nine theory. One, in particular, exhibits an orbital path that Planet Nine's gravitational influence cannot explain, casting a shadow of doubt over the entire idea. So, where does that leave us right now in this cosmic game of hide and seek? Planet Nine remains a truly tantalizing mystery, a gravitational ghost in the data. If it exists, its discovery would not merely add another dot to our celestial map, it would fundamentally reshape our understanding of how our solar system formed and evolved. It might be the smallest type of gas giant, or perhaps a bizarre, never-before-seen hybrid between a rocky planet and an ice giant. Its presence could even unlock profound secrets about why some worlds ended up close to the sun, while others were flung far into the frigid depths. But, and this is the profoundly frustrating part, definitive confirmation will not come easily. Even the most powerful ground-based telescopes struggle to pierce the unimaginable darkness at such extreme distances. A space probe, theoretically, could embark on such a monumental journey, but at current speeds, it would take well over a century just to reach the general vicinity where Planet Nine might reside. And remember, even if we launched such a probe, we still wouldn't know precisely where to aim it along Planet Nine's colossal, unknown orbit. That's the sheer elusiveness of this potential world. For now, Planet 9 endures as a ghost in the data, a possible giant pulling cosmic strings from the deepest shadows. Whether it ultimately proves to be real or a grand illusion, the very search for it is a powerful reminder of just how incomplete our map of the solar system truly is. We often bask in the illusion that we've charted every corner of our cosmic backyard, meticulously cataloging every major body. But the humbling truth is, there may still be entire worlds, massive and magnificent, patiently waiting to be discovered. And if one of them is as colossal and distant as Planet 9, then the most mind-blowing aspect of this entire saga might be a simple, yet profound, realization. Our solar system is far from done surprising us. Speaking of surprises, let's dive into another fascinating, albeit purely hypothetical, cosmic tale, the story of Phaeton. Imagine a mysterious object that once orbited between Mars and Jupiter, only to be obliterated by some catastrophic event in the early, tumultuous days of our solar system. This hypothesized space body, Phaeton, is a planet that exists only in theory, yet some intriguing evidence once suggested its dramatic demise might have birthed the vast rocky expanse we now know as the asteroid belt. At the dawn of the 19th century, the asteroid belt was still an unknown entity, but in 1801, a keen-eyed astronomer made a breakthrough, spotting the largest asteroid in our solar system, Ceres. At the time, with only Mars and Jupiter in their wide orbital gap, it was widely believed that a planet should reside there, and Ceres seemed a plausible candidate. The very next year, however, another astronomer discovered a second space object with a remarkably similar orbit, later named Pallas. These dual discoveries led scientists to a compelling conclusion. These two objects might not be single planets, but rather fragments, sad, shattered remnants of a much larger world that had once gracefully traversed the space between Mars and Jupiter. The subsequent discovery of two more asteroids, Juno and Vesta, only seemed to solidify this dramatic disruption theory. It wasn't until the 20th century that this hypothetical planet received its evocative name, Phaeton, borrowed from Greek mythology, meaning shining one. The myth tells of Phaeton, son of the sun deity Helios, who was granted permission to drive his father's fiery solar chariot across the sky. But Phaeton, lacking his father's divine control, lost command of the horses, causing the sun to veer wildly and threaten to incinerate the earth. Zeus, the chief deity, was forced to intervene, striking Phaeton down with a thunderbolt to save humanity, a fittingly dramatic name for a planet believed to have met such a cataclysmic end. The disruption theory proposed several explanations for Phaeton's tragic fate. The most obvious, a titanic collision with another massive space object. Some even posited another hypothetical body, Nemesis, our Sun's theoretical companion star. This companion, thought to be a red or brown dwarf, would have an extremely elliptical orbit, periodically bringing it close to the Oort cloud, a vast sphere of icy objects surrounding the Sun. Such close encounters could trigger a gravitational cascade, flinging comets and asteroids inwards, potentially causing a fatal impact with Phaeton. It's no wonder this hypothetical companion earned the nickname Death Star. The search for Nemesis has persisted for decades, but it remains an elusive, possibly non-existent, cosmic phantom. Another theory suggested Phaeton might have suffered some internal cataclysm, a planetary implosion that tore it asunder. However, as scientific understanding evolved, the disruption theory gradually fell out of favor. It was largely superseded by the accretion theory. This prevailing view suggests that the asteroid belt formed through the gradual accumulation of particles in the early solar nebula, a vast, gaseous, and dusty environment. Over time, these particles gently collided and stuck together, growing into larger masses. Gravity then pulled these clumps together, forming planetesimals, tiny planet-like bodies. These planetesimals continued to collide, sometimes merging to form protoplanets, which in turn grew into full-fledged planets. It's a cosmic snowball effect, where increasing mass attracts more material until the building blocks are exhausted, leaving large objects floating in space. Today, most experts believe the asteroid belt is not the wreckage of a destroyed planet, but rather the remains of a protoplanetary disk that simply never had the chance to coalesce into a planet. Jupiter's immense gravitational influence, a powerful cosmic spoiler, prevented these planetesimals from fully merging. So, while Phaeton makes for a captivating story, it has largely faded from the realm of serious scientific consideration. Let's circle back to our current cosmic enigma, Planet 9, and delve deeper into the modern hunt for this elusive giant. Remember that giant, donut-shaped region far beyond Neptune, more than 2.5 billion miles from Earth. That's the Kuiper Belt, and something genuinely bizarre is occurring there. The dwarf planets and countless other small objects residing within it refuse to behave normally. Instead of a random distribution, they exhibit peculiar clustered orbits, as if an unseen force is hurting them. And that force, scientists increasingly believe, might be a large, mysterious planet, a gravitational shepherd hiding in plain sight beyond Pluto. Our solar system, a majestic ballet of celestial bodies, consists of the Sun and everything gravitationally bound to it. This includes our 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Then there are the smaller, yet equally fascinating, objects like moons, asteroids, and of course, Pluto. For generations, Pluto held the prestigious title of the 9th planet, but its reclassification as a dwarf planet left a cosmic void, a sense that something was missing. Did scientists simply have a thing about odd numbers, or was there a deeper, gravitational truth waiting to be uncovered? And indeed, many now seriously propose the existence of a massive, icy planet lurking in the unfathomable distances beyond Neptune, a planet frequently referred to as Planet 9. Planet 9, as we've discussed, remains unseen, a theoretical titan. Yet, its existence is strongly inferred by the strange, clustered, and tilted orbits of those tiny, faraway Kuiper Belt objects. These orbital anomalies are simply too improbable to be mere coincidence. This powerful gravitational signature strongly suggests a hidden world, massive enough to herd these distant rocks into their peculiar patterns. If Planet 9 is real, it's estimated to be an impressive 5 to 10 times the mass of Earth. Its sheer distance would be staggering, hundreds of times farther from the Sun than Earth. While previous estimates varied, the latest models, potentially as recent as 2025, suggest its aphelion, farthest point from the Sun, could be an astonishing 290 times the Earth-Sun distance. Where did such a colossal world come from? Scientists have several tantalizing hypotheses. It might have originated as a much larger planet that was gravitationally kicked out of the inner solar system by Jupiter's immense pull during the early chaotic formation of our system. Or more exotically, it could be an exoplanet that formed around another star and was later captured by the Sun's gravity. It might even have been a rogue planet, wandering the interstellar void, before finding a home, albeit a very distant one, in our solar system. Despite intensive searches using the most powerful telescopes available, Planet 9 has yet to be directly observed. Its existence remains, for now, a compelling theory. However, a group of researchers recently employed a clever and innovative approach. They utilized data from two specialized space surveys, IS and Akari, which map the sky in invisible far-infrared light. Crucially, these surveys were conducted approximately 23 years apart, a perfect temporal gap given Planet 9's predicted incredibly slow movement. The team focused on specific lists from Akari, known for its superior ability to detect faint, moving objects in space. They then painstakingly calculated how bright Planet 9 should appear and how fast it should move, based on estimates of its potential size, distance, and temperature. They looked for matching blips in the sky that appeared in both IS and Akari data, but critically not in the exact same spot. A genuine planet would have shifted slightly over the 23-year interval, and to their immense excitement, they found 13 possible matches that fit the criteria for Planet 9. Their estimations for these candidates suggested a distance of 500 to 700 times the Earth-Sun distance and a mass of 7 to 17 times Earth's. After meticulously scrutinizing all the images, they narrowed their focus to a single, incredibly promising candidate. The detections were indeed in different locations in both surveys, and its appearance on the Akari map perfectly matched what one would expect from a slowly moving, distant object. It was observed on one date and conspicuously absent 6 months earlier, further supporting its authenticity as a moving body. But, inevitably, there was a catch. The older data isn't precise enough to definitively plot the exact orbital path of this potential planet. The team is now eagerly awaiting new follow-up observations using advanced cameras like DAM, specifically designed to spot faint-moving objects. These crucial observations will confirm if this candidate is indeed the long-sought Planet 9 and, if so, unlock untold secrets about the formation and dynamics of our solar system. If Planet 9 is ever definitively discovered, its impact on our understanding of the solar system would be nothing short of revolutionary. It would elegantly explain several baffling orbital anomalies. The tilted Kuiper Belt. Objects. Most planets orbit the Sun on a relatively flat plane. Yet, those distant Kuiper Belt objects are tilted by about 20 degrees relative to this plane. Planet 9's gravity could be the master architect behind this perplexing tilt. Clustered orbits. These tilted objects also appear to point in the same general direction, their orbits grouped together. A large, hidden planet could be gravitationally herding them, much like a shepherd guides his flock. Extreme tilted objects. Some incredibly distant, highly tilted objects defy explanation by known planets. Planet 9's immense tug could be the missing piece of this cosmic puzzle. Retrograde orbiters. A few exceedingly rare space rocks in the outer solar system orbit the Sun backward. A truly anomalous behavior unless a massive, unseen planet is dramatically messing with their paths. Stable cross-Neptune orbits. Certain far-out Kuiper Belt objects continually cross Neptune's path without being flung away. Planet 9's long-term gravitational influence might actually be helping to stabilize their unusual orbits. The super-Earth connection. The discovery of Planet 9, a super-Earth-type planet, more massive than Earth but smaller than Neptune, would bridge a significant gap in our solar system's planetary demographics. Super-Earths are incredibly common around other stars, but are notably absent in our own system. Finding one here would make our solar system far more representative of planetary systems observed across the galaxy. The human fascination with hidden planets far beyond Neptune is not a new phenomenon. Even before Pluto's discovery, whispers of unseen worlds persisted. As far back as 1880, astronomer George Forbes hypothesized the existence of two unknown planets way out there, one approximately 100 times farther from the Sun than Earth, and another at a staggering 300 times that distance. He believed these mystery planets were subtly tugging on the orbits of certain comets, much like Jupiter influences those closer to it. Then, in 2004, scientists stumbled upon a bizarre little world called Sedna. Its highly elliptical orbit around the Sun was unlike anything seen before, seemingly unaffected by any of the known planets. Its perihelion, closest point to the Sun, was far too distant for Neptune to be the gravitational culprit. This discovery ignited a fresh wave of speculation. Could Sedna have been nudged into its strange path by a hidden planet? Perhaps one even larger than Earth? Other theories suggested a star that once flew by our solar system long ago, or even a companion star that formed alongside our own. The plot thickened in 2014 with the discovery of another odd object exhibiting an orbit strikingly similar to Sedna's. This striking coincidence intensified the suspicion that something massive and unseen was indeed out there, subtly perturbing these distant paths. This effectively reignited the modern Planet X or Planet 9 hunt. At a 2012 meeting, scientist Rodney Gomes proposed a large hidden planet around 1,500 times farther from the Sun than Earth, suggesting it could explain the orbits of other peculiar objects, including some distant comets and centaurs, small bodies that wander between the giant planets. At that time, proponents of the Planet 9 theory envisioned it orbiting the Sun in an enormous, stretched-out ellipse, ranging from 400 to 800 times farther from the Sun than Earth, roughly 13 to 26 times farther than Neptune. Such a colossal orbit would mean a single year would last an astonishing 10,000 to 20,000 Earth years. Furthermore, its path wouldn't be confined to the flat plane of the other planets. It would be dramatically tilted by about 15 to 25 degrees. Its aphelion, the farthest point in its orbit, was predicted to lie in the direction of the Taurus constellation, while its perihelion, the closest point, would point towards Serpens, Ophiuchus, or Libra. As for its composition, Planet 9 is thought to be akin to Uranus or Neptune, possessing a thick atmosphere of hydrogen and helium and experiencing unimaginably frigid temperatures around 375 degrees. Its core would likely be iron, encased in a middle layer of rock and water ice. However, if it proved to be smaller and denser, it might lean more towards an Earth-like composition, featuring a rocky surface rather than a gaseous one. According to Mike Brown, if Planet 9 were real, a space probe using a powerful gravitational slingshot around the Sun could potentially reach it in a mere 20 years, a testament to the accelerating pace of space travel technology. As we push the boundaries of cosmic exploration, we encounter a bewildering array of exoplanets, worlds orbiting stars beyond our Sun, that utterly defy our Earth-centric notions of what a planet should be. From planets swathed in eternal darkness to those being slowly torn apart by their own stars, these bizarre worlds offer a chilling glimpse into the extreme and varied conditions the universe harbors. Let's delve into some of the most peculiar, hostile, and utterly enigmatic planets known to humanity. Get ready for a journey into NASA's very own galaxy of horrors. Imagine a world where darkness reigns supreme, a place where photons go to die. TORRES 2b, located 750 light-years away, is precisely that. This gas behemoth, 1.5 times more voluminous than Jupiter, possesses an uncanny ability to absorb light more efficiently than even the darkest charcoal. It's so dark that it reflects less than 1% of the starlight hitting it, making it the blackest known exoplanet. Forget a sky twinkling with stars. Here, it's an abyss. While its atmosphere is scorching hot, occasionally heated to temperatures resembling molten lava, it may display only a faint, eerie, deep ruby-red glow. This is a world that truly flips our understanding of a night sky on its head. Within the 55 Cancri system, a truly hellish world orbits its star in an uncomfortably tight, blistering dance. 55. Cancri is subjected to such unimaginable heat that an entire hemisphere of its planetary face has become a searing, roiling ocean of molten lava. Picture a burning, endless sea of liquid rock. Its other half is trapped in a perpetual desert of darkness, forever untouched by the light of its nearby sun. And between these two extremes lies a narrow, terrifying band of perpetual dusk, where twilight lasts for all eternity. The stark, violent contrast between the burning and the desolate creates an eerie, almost hopeless landscape. At first glance, HD 189-733b might appear to be an artist's breathtaking impression of an alien ocean world, its surface adorned with mesmerizing swirls of blue and white. But this beauty is profoundly deceiving. Those captivating patterns are the result of silicate particles, essentially microscopic glass in the planet's violently turbulent atmosphere. These particles conspire to create a horrific, inescapable storm of glass rain. That's right, razor-sharp shards of glass falling from the sky, propelled by cataclysmic winds reaching speeds of an astounding 5,400 miles per hour. Anything and everything caught in its path would be instantly ripped to shreds. Imagine a place where your very atoms are slowly, inexorably being torn apart. That is the grim reality for the planets in this system, thanks to their parent star, a pulsar. Pulsars are the super-dense, rapidly spinning remnants of massive stars that have exploded in spectacular supernovae. They unleash potent, relentless beams of electromagnetic radiation. These energy bursts are gradually erasing the very existence of the exoplanets in this doomed system, breaking them down at a fundamental atomic level. Their ultimate fate is to slowly dissipate, atom by atom, into the cold, unforgiving void of space. Ghost-like planets orbiting an undead star, a chilling concept indeed. Once upon a time, Kepler 70b might have resembled a gas giant like Jupiter, shrouded in a thick atmosphere. But its parent star suffered an explosive midlife crisis, expanding into a monstrous red giant, effectively gobbling up Kepler 70b in the process. Now, this planet is a fiery, scorched rock with surface temperatures that paradoxically exceed those on the surface of our own sun. The extreme heat is causing the planet to slowly evaporate, its days tragically numbered. Yet it survived being inside its star, a truly astonishing feat of cosmic resilience. Tragic might be the most fitting word for WASP 12b. Its massive, hungry parent star is pulling it into an oblong, distorted shape, reminiscent of a cosmic egg. As it spirals ever closer, the gravitational pull becomes agonizingly stronger, signaling an inevitable, fatal attraction. On a cosmic timescale, WASP-12b is already on its deathbed, being slowly devoured by its star. Its proximity is so extreme that its orbital period is just a single Earth day. This immense gravitational dance has transformed its very shape, a horrifying preview of its ultimate demise. Imagine a world so utterly contradictory that it boggles the mind. Gliese 436b. This planet is simultaneously scorching hot and eternally icy. Despite being hotter than an oven, its surface ice doesn't melt away. Instead, it burns continuously due to the planet's incredibly intense gravity, which keeps the water molecules compressed into a solid exotic state known as hot ice. It's a paradox of extremes, where fire and ice exist in impossible harmony. Even within our own solar system, we have our horrors. Our neighboring planet, Venus, is a nightmarish world with a hellish, crushing atmosphere, corrosive sulfuric acid rains, and surface temperatures that shockingly outstrip even those of Mercury, the closest planet to the Sun. It is a stark, terrifying reminder that even a world so similar in size to Earth can transform into an utterly uninhabitable inferno. It is, unequivocally, Earth's evil twin. Not explicitly in your list, but a fitting addition. HD 209458b, sometimes nicknamed Osiris, is an exoplanet located about 150 light-years away that is literally evaporating into space. Its atmosphere is being violently stripped away by the intense radiation from its star, leaving a comet-like trail of gas. It's a gas giant that's slowly shedding its very essence, a cosmic ghost in the making. Now for a true cosmic enigma, the planet LHS 3154b. This one, frankly, shouldn't exist, yet it does. Discovered rotating around a star significantly smaller and dimmer than our Sun, this planet is incongruously enormous. Such a tiny star, roughly 9 times smaller than our Sun, shouldn't have been able to gather enough material to forge such a massive world. It's like finding an ostrich egg in a chicken coop. A team at Penn State utilized a specialized instrument called the Habitable Zone Planet Finder, attached to a large telescope in Texas. This tool meticulously examines the light from dim, cool stars, looking for tiny wobbles in their speed caused by a planet's gravitational tug. This sophisticated Doppler technique allowed them to spot the impossible. LHS 3154b. Planets typically form in the swirling, gaseous, and dusty disks that surround young stars. Particles within these disks collide, stick together, and gradually accrete, or core accretion, building up solid cores that then attract more gas and dust. This process requires a substantial amount of material. Usually, bigger stars possess more gravity and thus larger, denser disks, enabling them to form larger planets. But LHS 3154's star is tiny, meaning its protoplanetary disk should have been far too meager, at least 10 times too small, to create a world 13 times heavier than Earth and similar in size to Neptune. Yet, this colossal planet, residing a mere 50 light-years away in the Hercules constellation and completing an orbit in just under 4 days, stands as a defiant challenge to our most fundamental theories of planet formation. New theories, such as gravitational instability, where disk material collapses directly into a planet, are being explored, but even these struggle to fully account for such a heavy planet forming around such a small star. It's a puzzle that forces scientists to rethink the very blueprints of cosmic creation. Another rule-breaking planet is Hala, orbiting a star named Bekdu. Like LHS 3154b, Hala shouldn't really exist. It's far too close to its star. Stars undergo dramatic transformations during their life cycles. When a star like Bekdu reaches its red giant stage, it swells immensely, typically engulfing or violently pushing away any nearby planets, leaving a path of destruction. Yet Hala, despite orbiting a red giant, has miraculously survived this fiery expansion. Even though Bekdu has now begun burning helium and shrunk to a smaller, more stable size, Hala remains unbothered, earning it the evocative nickname, the Forbidden Planet. This discovery profoundly challenges our understanding of how planets survive near aging stars. Two main theories have emerged. One suggests Bekdu was originally a binary star system, with Hala orbiting both. The two stars then merged before the red giant fully expanded, and the extra helium from the white dwarf component prevented the red giant from growing too large, allowing Hala to survive. The second theory proposes that Hala itself formed from the debris created when the two stars merged, making it an incredibly young planet orbiting an ancient star. Astronomers are now eager to study Hala further and search for more such forbidden planets. Then there's LTT 9779b, a planet that quite literally dazzles us with its extreme shininess. This hot Neptune reflects an astonishing 80% of the light from its star, a reflectivity comparable to a rough mirror made of aluminum or silver. Located 268 light-years away and discovered by NASA's TESS spacecraft, it completes a full orbit around its star in a blistering 19 hours. Its extreme proximity means surface temperatures soar to over 3,600 degrees. Normally, planets this close would have their atmospheres utterly stripped away, leaving only bare rock. But LTT 9779b defies this expectation. Its secret? Highly reflective, metallic clouds made of silicates and titanium salt. These unique clouds not only rain titanium onto its superheated surface, but also act as a gigantic mirror shield, reflecting so much light that the planet avoids overheating and losing its atmosphere. Its size also presents a challenge. It's significantly larger than Earth, whereas other planets found this close to their stars are either much larger gas giants or small rocky worlds. LTT 9779b is a smaller gas giant, an unexpected resident so close to its star. It is, in fact, the shiniest planet ever found, outshining even Venus. Yet, despite its cool appearance, its extreme temperatures and bizarre metallic rains make it an utterly inhospitable place for life. Our final rule breaker is WASP 107b, a planet discovered by the venerable James Webb Space Telescope. Located approximately 208 light-years away in the Virgo constellation, this super Neptune exoplanet completes an orbit around its star in a mere 6 days. While similar to Jupiter in size and experiencing scorching temperatures, its most striking characteristic is its incredibly low density. It is in fact the least dense planet we've ever discovered, making it remarkably fluffy. Further research revealed an even more astonishing detail. It has a tail. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from its star, creating a vast, comet-like tail of escaping helium. It truly looks like a giant fluffy comet in space. This extreme fluffiness, however, allowed astronomers to study its atmosphere in unprecedented detail. They found surprising elements like water vapor and clouds made of fine silicate particles, essentially extremely fine-grained sand. The planet's host star doesn't emit a lot of high-energy light, but because WASP-107b is so tenuous, this light penetrates deep into its atmosphere, creating sulfur dioxide, the distinctive smell of a lit match. In essence, it's a fluffy planet that rains sand and smells like matches. Researchers hypothesize that the sand clouds in its atmosphere form similarly to water clouds on Earth, but with silicate droplets. These droplets condense, fall, turn into silicate vapor in hotter layers within the planet, and then rise again to reform clouds. And once again, this planet could not have formed in its current close-in location. Astronomers suggest it likely migrated closer to its star from a more distant birth orbit, gravitationally attracted by some heavier neighbor. It also follows a retrograde orbit moving in the opposite direction to its star's rotation. All these discoveries about WASP-107b are rapidly changing our understanding of planetary atmospheres and dynamics, offering fresh insights into the profound mysteries of our own solar system. Let's shift gears dramatically and ponder a truly mind-bending concept. Have you ever considered Earth itself not just as a rock orbiting the sun, but as an intelligent entity, a living, breathing being with its own collective mind and survival instincts? When articulated this way, it sounds like the premise of a fantasy epic, where the very ground beneath our feet is conscious, perhaps even capable of thought. Imagine all the living things on Earth, every plant, every animal, every microscopic microbe, as a colossal, interconnected team. Each component plays a different, vital role, yet all are unconsciously working together to maintain and improve the planet's habitability. This is where the profound idea of planetary intelligence comes into play. Just as individuals and groups can possess intelligence, so too, perhaps, can an entire planet. Researchers propose measuring a planet's intelligence by its capacity to sustain itself indefinitely, its ability to ensure its own long-term survival, and, much like humans needing to collaborate to thrive, a planet's collective intelligence would be measured by the capacity of all life on it to cooperate towards this overarching goal. It's as if the planet itself is a complex, self-regulating system that instinctively knows how to care for itself. Think of forests, for instance, sharing vital nutrients through vast secret underground networks of fungi, keeping the entire ecosystem healthy. We, as humans, could certainly learn a profound lesson from such natural intelligence. If we were to indulge in pure fantasy and search for truly sentient, conscious planets, we might envision worlds like MOU from the Green Lantern comics, a specific planetary entity capable of altering its weather, manipulating gravity, controlling plant growth, and shaping its own surface conditions. Or what about the breathtaking Pandora from James Cameron's Avatar? Remember those mesmerizing scenes of flora and fauna, many with bioluminescent organs that reminded us of tentacles, enabling creatures to neurolink with each other and with the planet itself. It's as if the entire planet were one colossal brain, with countless trees, creatures, and other elements acting as its interconnected cells. While we are undoubtedly a long way from such profound planetary sentience, it's a beautiful thought experiment. At present, our human civilization exists in a stage scientists term an immature technosphere. This means we are still largely focused on developing and utilizing technologies that don't always serve the long-term well-being of our planet. We haven't yet achieved true planetary intelligence or a collective understanding of what's truly needed to act in concert for Earth's benefit. Instead, we largely operate as disparate individuals and groups. However, we are not at the worst stage. Researchers have outlined 4 distinct stages of Earth's past and potential future, illustrating how planetary intelligence could influence humanity's long-term destiny. The immature biosphere, billions of years ago, when life first sparked on Earth. At this primordial stage, the planet harbored only microbes on its barren lands, devoid of significant vegetation. Crucially, there was no global feedback loop. These early microbial communities lacked the collective capacity to significantly influence Earth's atmosphere or its other complex systems. Life existed on Earth, but it wasn't yet shaping the planet itself. The mature biosphere. This era spanned approximately 2.5 billion to 540 million years ago. During this period, stable continents formed, and the burgeoning biosphere began to exert a powerful and sustained influence on Earth. Life, through photosynthesis and other processes, started fundamentally altering the planet's atmosphere and geology, actively contributing to its habitability. The immature technosphere. This is where we find ourselves today, characterized by interconnected global systems of communication, technology, transportation, electricity, and computers. This stage sees humanity drawing vast resources from Earth's systems and profoundly impacting the biosphere. While undeniably advanced, it's considered immature because our technological activities often operate without a unified planetary consciousness or sustainable long-term vision, frequently creating detrimental side effects. The mature technosphere. This is the aspirational future, the stage Earth should strive to reach. In this envisioned future, technology would operate symbiotically, benefiting the entire planet. We would predominantly utilize sustainable forms of energy, such as widespread solar power, and our innovations would be harmonized with natural systems. Planetary intelligence, a sign of a truly mature planet, would be fully realized, with humanity operating as a responsible, integrated component. Researchers are actively exploring how we can consciously transition towards this crucial 4th stage. This framework emphasizes that individual actions truly matter. The collective activity of all life, from the tiniest microbes to the grandest forests, can profoundly transform a planet, elevating it beyond a mere lifeless rock floating in space. Through the biosphere, our home planet instinctively developed ways to host and sustain life billions of years ago, and it continues to do so. Our current challenge is to evolve a similar kind of self-maintaining system, but this time, within the context of our vast and powerful technosphere. There are, of course, intriguing exceptions to this rule. Ants, for example, while individually not the brightest creatures, when united in vast colonies, they achieve astonishing feats. They can collectively gather food many times their individual size, construct intricate nests, nurture their young, and even engage in forms of farming. They operate as a superorganism, a true hive mind, where every ant works seamlessly towards a common goal. Insects like bees and ants exhibit profound altruism, sacrificing individual needs for the reproductive success of their queen and the perpetuation of the colony. If a single massive ant colony were to somehow dominate an entire planet, it could theoretically act as a single, unified mind. tirelessly working towards the colonies and thus the planet's interests until resources were depleted. But even such a superorganism, in reality, would struggle to reach the levels of self-awareness and consciousness we imagine for a sentient planet. How would such a planet-sized entity communicate with itself? Ants utilize pheromones. Humans use complex nervous systems. Both are highly effective for organisms of their respective scales. But for an entity the size of an entire planet, instantaneous, efficient communication across vast distances would be a monumental, perhaps impossible, challenge. Communication within such a colossal entity would inherently be much slower than the speeds we experience with our modern digital networks. So for now, we'll continue to dream of worlds like Pandora. For millennia, humanity gazed upon the night sky and knew only 5 planets: Mercury, Venus, Mars, Jupiter, and Saturn. These celestial wanderers were visible to the naked eye or through rudimentary telescopes. But in the late 18th century, a monumental discovery reshaped our cosmic perspective. The famed astronomer Sir William Herschel, systematically surveying the heavens, stumbled upon a new, icy blue planet. Initially mistaken for a star, it was eventually recognized as a distant world, now known as Uranus. Situated more than 19 times farther from the Sun than Earth, Uranus is so remote that a single trip around our star takes a staggering 84 years. Herschel's relentless curiosity also led to other profound discoveries, including double stars and nebulae. Then, in the mid-1800s, scientists noticed something peculiar. Uranus's orbit wasn't behaving exactly as predicted. It seemed to be subtly tugged, as if by an unseen hand. The brilliant French mathematician Urbain Le Verrier, among others, hypothesized the existence of another, even more distant planet, using intricate mathematical calculations to predict its precise location. In a triumphant moment in 1846, Neptune was discovered through a telescope, almost exactly where predicted. Its faintness, due to its immense distance, meant it was utterly invisible to the naked eye. This was a profoundly exciting period, a testament to the power of mathematics and observation. It left the scientific community buzzing with a tantalizing question: how many other planets might be lurking in the darkness of our solar system? Soon after, in the mid-1800s, astronomers observed another celestial anomaly. The small, rocky planet Mercury was behaving strangely. Its orbit wasn't following the precise path dictated by Newton's laws. Again, Urbain Le Verrier stepped forward, theorizing the existence of an unknown planet situated even closer to the Sun than Mercury itself. He named this hypothetical world Vulcan, after the Roman god of fire, suggesting its incredibly hot surface could explain Mercury's peculiar orbital dance. Le Verrier never definitively claimed Vulcan's existence, but the possibility of discovering a new planet ignited a fervor among astronomers worldwide. Many committed themselves to hunting for Vulcan. Skeptics pointed out that a planet as large as Mercury would be incredibly difficult to miss, but the faint possibility of a smaller world too close to the Sun to be easily observed persisted. Theories proposed Vulcan to be around 13 million miles from the Sun. Mercury's closest point is 28.5 million miles, orbiting every 19 days and 18 hours, with a path tilted 12 degrees relative to other planets. Its closest point to the Sun would still be too near to be seen with the naked eye, even at twilight. The only hope of glimpsing Vulcan would be during a total solar eclipse or when it passed in front of the Sun, an event predicted to occur 2 to 4 times a year. So, whenever an eclipse darkened the sky, scientists eagerly peered towards the sun, hoping to catch a fleeting glimpse of Vulcan. Despite their intense efforts, the mysterious planet remained stubbornly elusive. Some astronomers claim to have spotted it, but no confirmation or verifiable evidence ever emerged. The theory of Vulcan lingered, awaiting better times or a more compelling explanation. That explanation arrived with Albert Einstein. You're familiar with his theory of general relativity, aren't you? It posits that gravity isn't a mysterious force, but rather a manifestation of space-time itself being curved by the presence of massive objects like planets and stars. Planets orbit the sun because the space-time around the sun is warped, essentially causing the planets to fall along the curves. Einstein applied this revolutionary theory to Mercury's unusual orbit. Unlike the other planets, Mercury's path wasn't a perfect ellipse. It subtly wobbled. Einstein proposed that the sun's immense gravity was significantly curving the fabric of space-time in its immediate vicinity, and this curvature subtly altered Mercury's orbit. It took time for the scientific community to test this radical theory, but it eventually proved to be the most elegant and plausible explanation, superseding the need for Vulcan. Even though Einstein's theory offered a superior explanation, some scientists found it hard to let go of Vulcan, especially given Mercury's inherent difficulty to observe. Ultimately, however, more and more scientists accepted Einstein's theory, even observing solar eclipses specifically to test relativity, not to hunt for Vulcan. Vulcan, however, is not the only hypothetical planet to have captured the public imagination. In more recent times, we've returned to the idea of a mysterious planet lurking in the outer reaches of our solar system. Though this one, Planet 9 or Planet X, is considered far more likely to exist, computer simulations consistently point to its presence beyond Neptune. This hypothetical giant, potentially 10 times more massive than Earth, would circle our Sun in a highly elongated orbit, on average 20 times farther than Neptune. A year there could span between 10,000 to 20,000 Earth years, compared to Neptune's 165 Earth years. A body of such immense size, moving in the vastness beyond Neptune, could indeed explain the unusual clustered orbits of smaller objects in the Kuiper Belt. That icy region beyond Neptune teeming with asteroids, comets, and other small bodies. Then there was the infamous hypothetical planet Nibiru. Remember the rumors of the world ending in 2012? One popular doomsday scenario involved Nibiru, which some claimed would collide with Earth at the end of that year. Of course, nothing happened. We're still here, safe and sound. But the idea of Nibiru was certainly compelling. Stories of Nibiru first emerged in the 1970s, when Zecharia Sitchin, in his book The 12th Planet, claimed it orbited the Sun every 3,600 years. However, a planet with such an eccentric orbit would wreak havoc on the orbits of all other planets in our solar system, a gravitational disruption that is demonstrably absent. Furthermore, if it were truly approaching Earth in 2012, it would have been easily visible to the naked eye, nearly as bright as Mars at its dimmest, and far brighter than the faintest stars visible from a city. Oh well, perhaps we'll have better luck, or rather, not have luck, in another 3,500 years or so. In 2011, a comet named Elenin appeared, which many mistakenly believed was Nibiru. However, comets and planets appear distinctly different through a telescope. A comet possesses a coma, a gaseous atmosphere, and often a tail, features a planet lax. Moreover, this comet didn't collide with Earth. It passed close to our Sun and broke apart. Its remnants continue their long journey into the outer solar system for the next 12,000 years. Our universe is a tapestry woven with both breathtaking beauty and profound terror. From the colossal structures of quasars and the enigmatic embrace of black holes to the unseen influence of dark matter, we've explored many cosmic wonders and nightmares. Yet, there are horrors of space and sheer mind-bending phenomena that continue to defy our current comprehension. We like to think we have a firm grasp on the cosmos, especially our own solar system. But the persistent hunt for Planet 9, the mind-bending reality of exoplanets that should not exist, and the historical tales of Vulcan and Phaeton serve as powerful reminders of the vast, unexplored frontiers of space. The truth is, our map of the cosmos is far from complete. There are still entire worlds, colossal mysteries, and fundamental principles waiting to be unearthed. And if Planet 9 is finally confirmed, or if we unravel the impossible physics of the forbidden planets, it will only reinforce the most profound truth of all: the universe, our own solar system included, is far from done surprising us, and that in itself is the most exciting prospect for any curious mind. So now I turn the question to you. What do you think is the biggest mystery still hiding in our own solar system? Let me know your thoughts in the comments below.